Okay, let's start. So, basis on the last class, what we are discussed about the different type of PLD. Yes or no? Do you remember? We are discussing like PAL, PLA, and PROM. So, any doubt about this design basis on the PAL or PLA? Any doubt? Because in the last class I discussing lot of point about the PAL and PLA. Do you have any doubt about the previous class? Okay. So yeah. I will provide you the material. So that is a different thing. By today or tomorrow, I will share. If I am not sharing any document related with the topic, you please knock me several times. Is that clear? Knock me several times. Because আমি অনেক কাজের মধ্যে থাকি, অনেক সময় ভুলে যেতে পারি. It's my fault. So please knock me separately. So now let's see the FPGA. So you remember in programmable device we are divided in two ways. The programmable device we are divided in two ways. So first we call combinational type, another we call sequential type. So in the combination type, three categorically with three different programmable device we consider. That is PROM, starting from PROM, then PAL and PLA. Similarly, for in case of the sequential type PLD, FPGA, CPLD, first is the SPLD, then CPLD, then FPGA. Field programmable gate array. So now we are looking forward about the field programmable gate array. Okay, so let's see. So what about this field programmable gate array is? This is first invented in 1984 by the Xilinx, and it is a reprogrammable logic device that implemented multi-level of logic. In case of the CPLD or SPLD, in the basic device don't have the multi-level of logic, but in the case of the FPGA, they have the facility of the multi-level logic, implemented multi-level logic. What are the advantage of that? If we are using multi-level of logic, then we can implement it a large circuit in FPGA. Now the principle of the FPGA, the field programmable gate array, is an integrated circuit. Obviously this is the integrated. So you already familiar with this FPGA. You are I have shown in, you see in the lab time also, and that can be configured by the user to emulate any digital circuit as long as there are enough resources. An FPGA can be seen as an array of configurable logic block. We actually learn, or we actually know this term several times. We discussed the several times that CLB. What about this CLB? Today I will discuss, and that will be connected through programmable interconnect, which is basically we call switches box. So how the switches box actually visible? So you can see here also. So before I start the FPGA detail, here we are considering to differentiate the ASIC and FPGA. So ASIC, you know the term. This is application specific integrated circuit, and the design must be seen for expensive and time consuming fabrication in the semiconductor foundry. When we are discussing the ASIC detail, that time you understand why I am written this point, that design must be same for the expensive and the time consuming. Whereas brought off the shelf and reconfigured by the designer themselves in case of the FPGA. Again, we are moving to the ASIC. What point we are considering? Designed all the way from behavioral description to physical layout. In case of the FPGA, this is the virtual field I already mentioned in the previous class also. There is a virtual field means they have some logic. Logic they have present. We just the configure. So that's the reason here I am writing no physical layout design. Design end with the bit stream used to configure a device. Now this is the typical Spartan 3 Xilinx starter kit. So here we are considering the FPGA part is the small IC considered as a FPGA. With this some switches for check the input and output. Having some button is again using for the verification of the input versus output. Some LED, this is also related with the input output. Now we look on the FPGA circuit. This is suppose the CLB are there, and this is the programmable interconnect, and this is the IO block. Now the terminology you have to have know. আচ্ছা এটা আমি লাস্ট ক্লাসে পড়াইনি তো এগুলো? Okay. So the terminology we know or we learn that first is the configuration. What is that? Bit that determine the logic called function plus interconnected. Another term is coming several times, that is combinational logic block, or maybe we can say configurable logic block. Both are same. Sometimes we call CLB as combinational logic block. Sometimes we call this is configurable logic block. Both are same. And configurable logic block basically make through some logic element. Next, the terminology we have to have know, that is LUT, which is called lookup table. When so various types of FPGA are present in the market. When the FPGA make through SRAM base, that time that kind of FPGA are associated with the lookup table. And what I am written here, SRAM used for truth table. Later on we discuss in today's class. Then the another terminology, that is the IO block. So we are familiar with this term IO block in the last picture. So what about this IO block? So IO block associated with IO pin, input output pin, with associated logic and electronics. Because you know, in every electronics device, when we move from somewhere to somewhere, automatically static electricity are generated. If static electricity is generated, that will be affect your logic. So that's why there is also a protection of cancellation of the static electricity. So that's why I'm written here that associated logic and electronics, isn't it? Now we are moving to the different things. So we understand this is the sequential type PLD, and when we are considering the FPGA, again we are divided in three types. So first one is SRAM based FPGA. The company who basically make this FPGA, SRAM based FPGA, that is Xilinx Altera. Next one is anti-fuse based FPGA made by Actel, and the last one is flash based. Flash means the term you heard in previously, hopefully. That flash based means, have you heard this term previously?
No, sir.
Yeah, you heard. You just recall yourself, guys.
Flash based.
Means, remember when we are discussing the ROM, different types of ROM, we are discussing ROM, PROM, EEPROM, UVPROM. Do you remember? That time we discussed this flash-based device. So this is flash-based device. This is EEPROM. The company involved to make this flash-based FPGA, that is Xilinx and the QuickLogic. Now SRAM based, we are just moving to the SRAM based FPGA, program logic function interconnect using SRAM. What about the advantage? Why we have preferred SRAM based FPGA? This is reprogrammable, dynamically reconfigurable, uses standard process. And what about the disadvantage? That is the SRAM burn power. If we compare, we already mentioned that three types of FPGA is there. If we consider the SRAM based FPGA, that will be require more power compared to other types of FPGA, and disturb the configuration bit also in case of SRAM. But why so? The major 2 points are there. This is the disadvantage for the SRAM. So why we are preferred SRAM? Because this is the term here I am mentioned. This is reprogrammable. So you are program or you are configure. Basically, you are configure the device multiple times. So that is the reason basically for research purpose we are actually preferred this SRAM based FPGA. Is that clear? Because nowadays we are mainly concentrated on the device which require less power. So this is the major disadvantage in this case. But the interesting part, what I am telling, is configure multiple times. So that's why we are preferred this SRAM based. So what about the CLB? The CLB of the SRAM base, the logic element includes a combinational function with the register. Use SRAM as lookup table of the combinational function. So this is a scenario. So what we are considering, this is the lookup table. This is the lookup table or configuration bit is there. This is multiplexer one consider. So using this, we are actually configured the program. Suppose we take a consider we are writing a program like 2 input XOR gate. if we are implemented two input XOR gate, what about the truth table, guys? Suppose A and B is there, and A has the output, then 0 0 0 1 1 0 1 1. This part is not written in the books also. So just learn, just see very carefully. The output is 0. Tell me. 1 1 0. This is the truth table of XOR gate. Now, what about our circuit? So the circuit is in this way to write. This is LUT. Yes or no? And we are having a multiplexer here. We are having a multiplexer. So in the lookup table, the interesting part, already they have, this is 4 cross 1 multiplexer. So they have the 4 block. This is 0, this is 1, this is 1, and this is 0. And the interesting part is that this will be connected with 4 cross 1 mask. This is your I0, this is I1, this is I2, and this is I3. This is your F, means your output. This one is F. We are considering F. And 2 select line is there. 2 select line is there. Suppose, for example, this is S0, this is S1. Usually what we are doing, this is A, this is B. And if we see here, this circuit we are considering as logic element. This is your logic element. Is that clear, guys?
Yes.
Good. Now, just check. When you are written a program in VHDL program, what you are written in this case? So suppose we are written entity XOR underscore 1 is, then we are write code A comma B as a in bit. Sorry. A comma B is a in bit semicolon. And F as a out bit. Then we write in XOR underscore 1. Then what we are written, architecture, data flow of entity is XOR underscore 1 is, then we write down begin, then F less than equals to A XOR B semicolon, then in data flow. Are you agree with me? Yes or no? Okay, so this is my program. So what we are doing in the case of the FPGA, we create a project. Then under the project, we create a module. Yes. Then what we are doing, we are written this program, and after that, we are synthesize the whatever you written in the module, and then what we are doing, we are downloading into the FPGA. Yes. And when you are downloading the FPGA actually configure like a two input OR gate. Are you agree? Are you agree? Yes. Now, what we are doing, if we switch on the in part of the input, according to the logic, we get the output as LED, isn't it? Now, actually, what happened inside the FPGA kit, FPGA board? This is absolutely research topic. This class for MTech, so that's why I'm discussing lot how it's work actually. So when you are downloading, that means there is a lookup table, SRAM based lookup table is present. Some of the lookup table size is 4, some of the lookup table size is 8, some of the 16, maybe 32, maybe 64, isn't it? So when you are downloading the logic, they automatically understand. There is no automation because you already written your input part is 2. So 2 means, so how many combination is there? 2 to the power n. That means n equal, if n equals to 2, so that means how many combination we get? 4. Yes or no? Say they automatically choose the lookup table who having the capacity of 4 combination. Clear? 4 combination of what? Basically the 4 combination of the output. 4 combination of output. So basis on that, you can see here in the lookup table portion what I am written 0 1 1 0, and we are considering one multiplexer which is basically 4 cross 1. So 4 cross 1 means we are considering we are connected with the lookup table I0 connected with 0 value, I1 connected with value 1, I2 connected with value 1, and I3 also connected with 0. Up to this, any doubt? Now, the question is that, what about the select line? Select line actually your switch, FPGA board switch. If we give the value in place of A and B, that means we of the value that is 0 0. What will be the answer to get in F? What will be the answer? If we put the value 0 0 in A and B, else S1 S0, what will be the answer? So 0, that 0 is came from where? Exactly. মানে কনফিডেন্ট নেই কেন, এরকম মানে গেঁতিয়ে গেঁতিয়ে অ্যান্সার দিচ্ছিস কেন? তুই যখনই ওটা সিলেক্ট করছিস ও তো এখান থেকে এসে এখানে আউটপুটটা দেবে, ইয়েস অর নো? অভিষেক ক্লিয়ার হয়েছে? সুমিত? So we get the answer as output is 0. Output is 0. What about next? In place of A, we write again, sorry, 0. In place of B, we write 1. What about the answer we get? Which one? I1 or I2? I1. This is the second value we get. Clear? So how actually FPGA is work? Now is that clear to all? যদি ডাউট থাকে বলতে পারো। এটা কিন্তু পুরোটাই মানে একদম কনসেপচুয়াল, এটা কোনো বইতে পাবে না, এটা একদম রিসার্চ পেপারে রয়েছে, সেখান থেকে উদ্ধার করে এই জিনিসটা দেওয়া। তো এনি ডাউট আপ টু দিস? Any doubt up to this, guys? Tell me.
No.
Just a second, please wait. আপনার নরমাল যেটা হবে যখন দেখছেন এরকম যাচ্ছে না, এখানে যাবেন, লাইট মোডটা অন করে দেবেন, তো রিঅ্যাক্টিভ ওয়েট করবেন 1 মিনিট বা 5 সেকেন্ড, তারপর ওটা তুলে দেবেন। ও আচ্ছা,
অনেক সময় না ঘুরে যায়, সেটা কি করে করবো বলো তো, বোঝাই যাচ্ছে না। আর বলবেন না।
Am I audible? Am I audible?
Yes, sir.
Yeah. So up to this, any doubt? Okay. Thank you very much. So now we are moving to the practical scenario. So this is the program we are written. This is the half adder using data flow. So after written the program, what we are doing, we are actually check that code is work or not. So we are synthesize the process, and after synthesization, what we are getting, that is the viewer synthesis, basically technological schematic. This is a view of technological schematic we get in this window, where is written A, B, C, and S. If we are double click on this, we get two separate lookup table they consider. And suppose we are click on the either any of the lookup table, we get that lookup table actual configure as AND gate. Is that clear? বোঝা গেছে কিভাবে কাজ করে, how it's work? অভিষেক বোঝা গেছে? বীরেন্দ্র, সুমিত বোঝা গেছে যে কিভাবে এটা অ্যাকচুয়ালি কাজ করছে? Is this interesting or not? So I just show you only one lookup table. I show you just only one lookup table, that is the XOR. Here you can see the AND. So if we write the program of full half adder, we require 2 gate only. One is the XOR and another is the AND gate. Clear? So that configuration done by the only SRAM based FPGA. Now we are coming to the next point, that is anti-fuse. What is that? This is permanently programmed and make a connection with the electrical signal more reliable than the break up connection. And we are using some resistance of 100 ohms and multiplexer based design. So so previous one, what we are doing, that SRAM based, we are considering lookup table. When we are considering make a circuit using anti-fuse based FPGA, that time that circuit actually made through the multiplexer. You remember in when you are in second year in BTech, that time you make a design using multiplexer. Do you remember, guys? Design using multiplexer. যে কোনো মানে তো ধরে নে AND gate, NOR gate, half adder, full adder are implemented using multiplexer. ছিল তো আমি জানি, ওদের মাথায় কতটা আছে সেটা হচ্ছে সবচেয়ে আমার বড় ডাউট। So suppose if you get a question like you discuss anti-fuse based FPGA, so you just take any of the design, like half adder you can choose, or you can choose 2 input XOR gate, 2 input AND gate, whatever you can take, and you make the design using multiplexer base. That's all, isn't it? I just show you some anti-fuse structure. So this is the fuse material. This is the fuse. This is the fuse material we are using, and this is the 2 metal are there, and in between the anti-fuse material or fuse material is there. So what happened? I just give you a simple example. বাড়িতে ইলেকট্রিক্যাল ফিউজ দেখেছিস নাকি সবই এমসিবি? সুমিতের বাড়িতে ফিউজ আছে, তো ফিউজে কি থাকে ভেতরে? কানেক্টর থাকে তো একটা, ওই অনেক সময় একটু বেশি লোড পড়লে ওই কানেক্টরটা কেটে যায়, তখন আবার একটা তার জুড়ে দিয়ে আবার আমরা ফিউজটা লাগিয়ে দিই, আবার বাড়িতে সুন্দর লাইট ফাইট চলছে, তাই তো? This is called the fusing technology. Here what we are using, that is anti-fuse technology. That means normal অবস্থায় ওটা ফিউজিং থাকছে না, certain voltage আমরা ইলেকট্রিক্যাল পালস অর আমরা we can say the voltage আমরা যখন ওখানে অ্যাপ্লাই করছি ওটা ফিউজিং হয়ে যাচ্ছে। ক্লিয়ার? বোঝা গেছে? So difference between fusing structure and anti-fuse structure. I just give you the simple example. এই ছাগলগুলো বলবি ক্লিয়ার হয়েছে? উত্তর দে, হ্যাঁ বল। একটা ইলেকট্রিক্যাল পালস এখানে দেয়া হচ্ছে, এখানে যে অ্যান্টিফিউজ মেটেরিয়াল আসছে সেইটা এখানে কানেক্টেড করছে, এটা ইনিশিয়াল পালসটা গিয়ে যখন এখানে হিট করছে একটা সার্টেন ভোল্টেজ পাঠানো হয়, ঠিক আছে? যখন এখানে হিট করছে, হিট করলে এই মেটেরিয়ালটা তখন কানেক্ট করছে মেটাল 2 আর মেটাল 1 এর সঙ্গে। মানে জিনিসটা এরকম আছে, কিরকম বলতো, আমি সেটাই তোকে বোঝালাম যে বাড়ির ফিউজে যদি কারোর ফিউজ থাকে, ছোটবেলায় দেখেছিস তো ফিউজে কি থাকে, একটা তার কানেক্টেড থাকে তো। তো এর ক্ষেত্রে এরকম একটা হলো যে এমন একটা ভোল্টেজ হলো ওটা অটোমেটিক্যালি একটা তার মতন অন্য জায়গায় মানে অন্য পোল থেকে আরেকটা পোলের সঙ্গে চলে এলো, এসে কানেক্টেড হয়ে গেল। সো ইটস লাইক দ্যাট ওয়ে, ঠিক আছে? মানে এখানে ইনিশিয়ালি এটা কিছু থাকে না, ধরেন এইটা দুটো পার্ট, দুটো মেটাল, কিছু থাকে না, কিন্তু এখানে যেটা থাকে হচ্ছে ইন বিটুইন একটা মেটেরিয়াল থাকে, এই মেটেরিয়ালটাকে বলছি অ্যান্টিফিউজ মেটেরিয়াল, ঠিক আছে? যখন এই মেটেরিয়ালটা থাকে তখন ওটা কন্ডাকশন মানে কিছু হচ্ছে না। এবার যখনই আমি ইফ উই অ্যাপ্লাই সাম ভোল্টেজ, certain voltage, তখন what actually we have seen that এটা কানেক্টেড হয়ে যাচ্ছে, this part actually connected, বোঝা গেছে এবার? তো এটার ফিজিক্স নিয়ে মানে we are not bothered about the physics of the antifuse structure because it's not necessary for you. I just tell you because the antifuse material is there, but what about this concept of this antifuse material, isn't it? So that's why I'm discuss about this antifuse structure, nothing else. But whenever if you face a question that written, you just give an example of antifuse type of FPGA, that time you just take a example as a circuit, like for example and or whatever, isn't it? And that circuit you make through the multiplexer base. So if the question associated with SRAM base, that time you are given the design like that lookup table base, and if design using antifuse, that means you are using multiplexer base. Clear? So this is the example. Suppose this is the NOT gate example. This is the NOT gate example. The logic block I already mentioned in the CLB under logic block. This is based on the multiplexer. If your output is 0 and 1, whatever you give, just get a opposite value. So this is the example of the multiplexer based FPGA. This is the truth table and this part is the circuit. This is typical larger logic block are there. So whenever we consider the logic block, you remember using multiplexer. If we are making a design, that time we are using AND and OR gate usually. So that's why here you can see the AND and OR gate as a what I say as a select line they consider. This is some example. This is Actel. They are making antifuse type of FPGA. Actel 54SX logic element. Don't require to remember all those things. For example, I'll just show you this slide. Now we are coming to the flash memory or flash program based FPGA. We are discussed previously also. Flash means is an electrically erasable ROM or PROM. It's called EEPROM, isn't it? And that kind of is like your pen drive device is the flash based device, isn't it? And it's allowed this is basically reprogrammable without boot up the procedure or process, and that will be made using AND and OR gate, AND and OR gate, because you know how to make the PROM. So the difference between PROM and EEPROM, that is the fusing part, nothing else. আমরা and or এই পার্টটাকে আমরা কি করেছিলাম মনে আছে? ভার্টিক্যালি and horizontally আমরা ক্রস করেছিলাম each other. Do you remember guys? ভার্টিক্যালি horizontally আমরা ক্রস করেছিলাম মনে আছে? So এখানে সেটাই হয়, but এখানে যে fusing processটা রয়েছে is a little bit different. So that's why its name is electrically erasable PROM. So many times we can reprogram, but the problem is that it's not like your SRAM based FPGA. SRAM based যদি আমরা 50,000 times আমরা কনফিগার করতে পারি, This is 5000 or 500 times আমি configure করতে পারবো, that is the difference. And the logic is virtual logic is making through the basic gate. So either and or, this is the previous technology. So in present technology is either NAND and NOR. Clear? So NAND NOR দিয়ে বা AND NOR দিয়ে যে কোনো সার্কিট তোমরা করতে জানো, অলরেডি তোমাদের শিখিয়ে দিয়েছি ইন টাইম অফ দ্য PLD, PAL এর সময়। দ্যাট ইজ দ্য এক্সাম্পল অফ দ্য ফ্ল্যাশ বেস FPGA। বোঝা গেছে? তিনটের এক্সাম্পল গুলো কিভাবে সেট করতে হবে সেইটা আমি কিন্তু ডিসকাস করছি আজকে। Now, flash, this is the technology, flash program switch, not required to understand this part, is not required now. Now I just keep this one. This is a multiplexer base. Now we are coming to the interconnect. So three types of configurable logic block we already discussed. Now you are coming to the interconnect. So interconnect, this is also a very interesting, that is the CLB are connected each other with switching box. This switching box is basically configurable. This is also a configurable. The interesting part is that this is not our, the controlling part is not our hand. What we are actually says that if this is the configurable logic block, this color shown as interconnected network, and this arrow is connected with the outside world, that is IO signal or IO pin. Clear? If we maximize, if we zoom, what about this switching box? This is nothing but a pass transistor. Do you know what about the pass transistor? Do you know, guys, what about the pass transistor? Guys, আরে পাস ট্রানজিস্টর তো মিলি ম্যাডামে পড়ানোর কথা, পড়িয়েছেন তো, কেন মানে এত ভুলে গেলে কি করে করাবো আমি ক্লাস? This is the NMOS we are using. If we give the value of 1 in this position, this will be connected. If we give the 0 value, this will be not connected. So this is the example. So that configure by FPGA themselves. এটা আমাদের হাতে নেই। Is that clear? পাস ট্রানজিস্টর যদি না মনে থাকে, এইগুলো তো সিম্পল জিনিস। So in the switching matrix or switching box, so this box, basically this box having a 6 pass transistor per switch matrix interconnect point, isn't it? So basis on that we just deal the interconnection, we make the interconnection. Now programmable wiring, organized into 2 channel many wires per channel connected between the wire made at the programmable interconnect point, and must choose the channel from the source to destination wires within the channel. So this is the good example of pass transistor or programmable interconnect point. So this is like also a D flip-flop. Do you remember the D flip-flop? Do you remember the D flip-flop? What about the output of the D flip-flop? Tell me. What about the output of the D flip-flop? হ্যাঁ
pricing হলে স্যার করে 0 আসে,
হুম হুম
0 হবে আর 1 হলে
So same logic are using in the pass transistor also, isn't it? So this is the example of interconnect point. In case of SRAM, that will be configured by the SRAM cell. So SRAM cell means this is having a two value, we are subdivided two value, either 0 or 1. So basis on that, this interconnect will done. Clear? So that means যদি এটা 1 হয়, এটা যদি 1 হয় আর এর ভ্যালুও যদি 1 হয়, তাহলে কি হবে? এটার সঙ্গে এটার কানেক্টেড হয়ে যাবে। Yes or no? হ্যাঁ, এটা এখানে সেটাই হবে। এটা this is a pass transistor base we call, isn't it? Nothing else. This will be connected. So they follow the horizontal and vertical line. That means they have some structure of routing. They follow the routing structure. Choosing the path, this is a logic element. They are choose the path, shortest path they are choice. You just see, এই পাথটা যদি আমরা চয়েস করতাম, এই পাথটা যদি চয়েস করতাম, এটা বেটার না যে পাথটা আমি চয়েস করে দেখালাম, which one is shortage? More shorter. এই বক্সটা কি? এই বক্সটা কি বলতো? This box, tell me, এই ইয়েলো বক্স গুলো কি? এইগুলোই সুইচ। ঠিক আছে, এখানে ধরুন চারটে রয়েছে, ওই আমি একটা আগের এক্সাম্পল দেখালাম ওরকম। এবার এইখানে যদি 0 থাকে, এটা যদি 1 থাকে, এ কিন্তু কানেক্টেড হবে না। এই যতক্ষণ না পর্যন্ত 1 হবে ততক্ষণ অবধি এটা কিন্তু কানেক্টেড হবে না। সো ইন দিস ওয়ে, so 3 types of wire are basically we found. One is the short wire, global wire, and special wire. What about the short wire? Is basically local element connector. What about the global wire? This is the long distance buffer communication. We are using that kind of, what I say, wire. And special wire basically deal with the clock. This is called the wiring channel. This is a switching box. And this is the permanent, which is basically anti-fuse. Sorry, it's not. This is permanent anti-fuse material. If we are making the fusing, then this will be permanent. And you know, the design made through the multiplexer base. So basis on that, they have interconnect logic. This is also using the pass transistor. They having a 4 types of interconnect in case of the Spartan 2. This is SRAM base, local general purpose dedicated and IO pin. Now we are coming to the input output block. In input output, one is the 3-state connection is there, another is the input or output. So 3-state, you know, তোমরা আইসি ইউজ করেছো ইন কেস অফ ইন টাইম অফ দ্য ল্যাব, বিটেক ল্যাব। তো আইসি তে মনে আছে 3টে লাইন কি কি থাকতো? enable line এর নাম শুনেছো কেউ? So input, output and enable line এর একটা পার্ট থাকতো। So basis on that 3-state buffer বলো। ট্রিগার মানে কি?
external কোনো input আর কি দেওয়া হবে, just কোনো response type এর কিছু একটা দেওয়া।
ট্রিগার মানে তুমি এক্সটার্নাল কিছু একটা ট্রিগার দিচ্ছ, তাই তো?
হ্যাঁ,
আর এনেবল মানে কি? এনেবলের অপোজিট কি? ডিসেবল। মানে আমার যখন মানে আইসিতে যখন আমরা কাজ করতাম তখন দুটো করে আইসি ধরে নাও, একটা মানে একটা আইসি ভেতরে দুটো করে পার্ট রয়েছে, মানে আমি ধরে নাও 4x1 মাল্টিপ্লেক্সার বলছি। তো আমার যেটা ডিজাইন প্রপোজ ডিজাইন আছে, বেসিস অন দ্যাট আমার একটা মাল্টিপ্লেক্সার দরকার। তো সেই অনুযায়ী আমি একটা ভোল্টেজ দিতাম, ঠিক আছে? ভোল্টেজ দিয়ে ওটাকে অ্যাক্টিভেট করতাম, আর একটা কিছু দিতাম না, ওটা ডিঅ্যাক্টিভেট থাকতো। আর সার্কিট ট্রিগার করাচ্ছ, মানে ট্রিগারটা অন্য অলমোস্ট সেম, বাট অন্য কাজে আমরা ইউজ করি ট্রিগার কথাটা বেসিক্যালি, টগল ট্রিগার এই কথাগুলো, ঠিক আছে? আর এনেবল লাইনটা কিন্তু ডিফারেন্ট থিং, মানে এনেবল আর ডিসেবল এখান থেকে এই টার্মটা এনেবল করছি, একটা সার্কিটকে আমরা এনেবল করছি, মানে আমি যেটা বুঝি আমি সেটা বললাম। ক্লিয়ার? Now, what about the others features is there? Register is there. There is a voltage level are there. And last point, we already mentioned that the special arrangement for avoiding the static electricity. কারণ একটা জিনিসকে যখন এক জায়গা থেকে আরেক জায়গায় নিয়ে যাচ্ছ, মুভমেন্ট করাচ্ছ, স্ট্যাটিক ইলেকট্রিসিটি আসবেই, সেখানে কারোর কিছু করার নেই। তো সেই স্ট্যাটিক ইলেকট্রিসিটিটা অ্যাভয়েড হয় through this special arrangement they have. আমি অত ডিটেইলে যাচ্ছি না, ডিটেইল যত যাব ততই তোমাদেরও পড়তে হবে। So example of FPGA family, this is SRAM based FPGA family, that is Altera, Atmel, Xilinx. Antifuse is basically Actel, Xilinx already mentioned, and Quick Logic family is also there for antifuse. Now we are coming to the very interesting difference between CPLD and FPGA. We already know the difference between ASIC and FPGA. Now we are coming to the CPLD and FPGA. We just give some point like architectural density, speed, interconnect, power consumption. So basis on that, CPLD architecture is PAL based, programmable array logic based, whether the FPGA is a gate array. Density wise low to medium, where the FPGA is medium to high. Up to 1 million of gate are there in case of FPGA. If we are considering speed, so less complex the CPLD. So this is first predictable. In case of FPGA, this is application dependent. And you have seen that in case of the interconnect, I already mentioned they follow the routing rules. So FPGA, they follow the routing rules, and in case of the CPLD, but present CPLD all are follow the routing rule, but previously this is crossbar. Crossbar means it's a haphazard. They are not follow the routing algorithm. and basis on the power consumption, CPLD is required high. FPGA again, I can say that depend on the application. When you are written in the exam time, you write the depend on the application, and you can also write the medium, but CPLD is required more high. So there is a question that sir apni bollen FPGA number of gate, millions of gate is there, is application dependent, but CPLD is more faster, predictable, low to medium density. So why the power consumption is high compared to the FPGA? So that is depend. The VLSI design cycles, if you found, there is a part are present that is physical level design. So when we are going through the physical level design, so three major part are there. That is the floor planning is there, routing is there. So FPGA is more planned circuit, planned and blank circuit, but the CPLD is not much planned compared to the FPGA. Clear? So that's why the power consumption is high compared to the FPGA. So that's all about the FPGA history, geography, everything. So do you have any question, guys? Response. Okay. Now we are we just show something. Is this visible? Hopefully. So now we are morely concentrate on how to write a program in case of the exam. So I just show you the thing. So how to start? Suppose you get a question like in this way, right? Half adder program using VHDL. So how to write? This is very important. So what we have written first, we this is followed for your lab also. The steps followed in your lab also. So first, what we are doing when we are considering to write down the half adder. So first we write the block diagram. We just draw the block diagram. This is A and B. This is S and C. You can write this is sum, this is carry, and the name of the circuit is half adder. This is the block diagram. Then we are written the module hierarchy. So here you write or draw basically. This is your project. Half underscore adder. Then you write main module, write half underscore adder dot VHD. Then what about the next one? Logical statement. You write S equals to, you just give the symbolic representation and C as A dot B. Clear, guys? Up to this? Yeah. Then you write truth table, where you mention A, B, sum and carry. 0 0 0 1 1 0 1 1. Yeah, this is 0 1 1 0 0 0 0 1. So then you write VHDL program of H half underscore adder dot VHD. Then what I am written? See, library IEEE use IEEE dot std underscore logic underscore 1164 dot all. You just check and verify that semicolon is there or not, and not remember. Then you write entity half underscore adder is port A colon in std underscore logic. I just follow the Xilinx, isn't it? Xilinx code. And whenever you write in time of the exam, you also follow the Xilinx version. B in std underscore logic semicolon, then sum out std underscore logic carry out std underscore logic bracket close semicolon. Then we are written in half adder. Then what we are written? Architecture data flow of half underscore adder is. Then write begin. Then S less than equals to A XOR B and C less than equals to A and B. Then we write in data flow. Clear, guys? These are the steps.
Yes.
So first, what we am written? I'm written that the block diagram. Then we are written the module hierarchy. Then logical statement, truth table, and after that we write down the VHDL program of that half adder. these steps will followed in both cases, in time of the exam and also in your lab. Follow. Under the main module, we are considering two sub-module. If we are considering half adder, that then half adder making through XOR and AND gate. So the both the and XOR gate is a sub-module. In time of the exam, I just tell you clearly, if you get a question like a 10 marks question to make a program using structural way, that time you also write down the sub-module program, isn't it? সাব-মডিউলে প্রোগ্রাম লিখতে হবে যদি 10 নম্বরের কোশ্চেন থাকে, যদি 5 নম্বরের কোশ্চেন থাকে, ডিপেন্ড অন দ্যাট। ধরে নাও 4x1 মার্কস করতে বললাম 2x1, তখন 2x মার্কস লিখবে, 4x মার্কসও লিখতে হবে, ঠিক আছে? 2x মার্কসটা ডেটা ফ্লো দিয়ে লিখলে ক্লিয়ার। কিন্তু ধরে নাও 2 মার্কসের কোনো কোশ্চেন আছে যেখানে বলছে 4x1 মার্কস স্ট্রাকচারাল ওয়েতে লেখো, তখন জাস্ট প্রোগ্রাম লিখে ছেড়ে দেবে, তখন অত কিছু দেওয়ার দরকার নেই। দিস ইজ the sample of the 10 marks question or 5 marks question. This is not the sample for the 2 marks question. Clear? কারণ প্রোগ্রাম প্রচুর পাবে, সেই কারণেই আমি বললাম। কি প্রোগ্রাম পাবে আই ডোন্ট নো, দ্যাট ইজ বেসিক্যালি ইওর এক্সাম। তোমাদের অফলাইন এক্সাম হচ্ছে, সো দ্যাটস ওয়াই আই এম টেলিং ইউ দ্য ভেরি ক্লিয়ারলি যে কোনটা কি করতে হবে সেটা কিন্তু আগের থেকে ভালো করে প্র্যাকটিস না থাকলে, অভ্যেস যদি না থাকে, পরীক্ষার সময় কিন্তু একদম পারবে না। ক্লিয়ার? সো আমি আরো একটা দুটো ক্লাস নেব, আজকে এখানে এন্ড করছি, কারণ এবারে বদহজম হয়ে যাবে, তোমাদের শরীর খারাপ হয়ে যাওয়ার চান্সেস আছে। ক্লিয়ার? আমি জাস্ট বিফোর আই জাস্ট লিভ, আই জাস্ট শো ইউ দ্য ওয়ান থিং, জাস্ট এ সেকেন্ড, ডোন্ট লিভ, জাস্ট এ সেকেন্ড। তো এটা তোরা সবাই ফ্যামিলিয়ার রয়েছিস, সেখানে 2x1 মার্কস আমি তোদের ল্যাবেও করতে দিয়েছিলাম। সো ইউ ক্যান সি হিয়ার, এটা স্ট্রাকচারাল ওয়েতে আমি এখানে ডিজাইনটা করেছি, ইজন্ট ইট? এবং এইটা যখন ইমপ্লিমেন্টেশন হয়েছে, দ্য ইন্টারেস্টিং পার্ট আমি কেন দেখাতে চাইছি, দেখ টেকনোলজিক্যাল ভিউটা হচ্ছে আমার, এটা ছিল টেকনোলজিক্যাল ভিউ, ভিউ অফ সিমেট্রিক্যাল টেকনোলজিক্যাল স্কিমেটিক। ইয়েস, পুরোটাকে সিনথেসাইজ করে আমি জাস্ট একটা জিনিস, আই জাস্ট শো ইউ দ্য থিংস। So this is a schematical view, this is a technological schematical view. If we are click on that, you can see here, so they are considering, I just minimize the, they are considering lookup table, 2 lookup table with this associated some multiplexer. It's a depend, কিন্তু lookup table কি করে কনফিগার করা হয় সেটা কিন্তু আমি অলরেডি তোমাদেরকে বুঝিয়ে দিয়েছি। ক্লিয়ার গাইস? বাবা ঘুম পেয়ে যাচ্ছে তো, তোদেরই তো হাই তুলছিস তোরা। So ठीक है, so next day I will start with the physical level design and VLSI design cycles, isn't it? ওটা করলে আমাদের অলমোস্ট কমপ্লিটেড দিকে। আর একটা ছোট্ট পার্ট থাকবে, ক্যাট টুলস নিয়ে একটুখানি গল্প করব। তো এখন আমার দুটো ক্লাস আছে, আজকে এটা এক্সট্রা ক্লাস নিলাম, সো কমপ্লিট হয়ে যাবে, কোনো অসুবিধা নেই।